So let's just talk about FPGAs, or field programmable gate arrays, in kind of a very general sense. Meaning, what I'm about to explain isn't necessarily how FPGAs works, but it can kind of give you an idea of what's happening underneath the hood, or what's happening in the chip. So the key thing here, right, is we have these gate arrays. And so you can imagine that an FPGA has these elements, these what I have in the squares, where they're selectable gates, meaning that I could say, I want this one to be an AND gate, and this one to be an OR, and this one to be not. And we do know that we can make any function using just ANDs, ORs, and NOTs, but an FPGA might have more functionality than just ANDs, ORs, and NOTs. But just for this example, this is what our logic elements has. It's got ANDs, ORs, and NOTs. So an FPGA allows you to select which gate is used for these logic elements, and it also allows you to select how they're interconnected. And we do that through programming Verilog, right? Verilog gives FPGA instructions on how to be configured. So suppose we want to make this design right here. We would specify our Verilog. There's a couple ways that we could do it. But what would happen is at some point it would say, all right, we need this AND gate, and we're going to need an OR gate as well. So we're going to use, we've got three logic gates, so we're going to use three of these logic elements. And this AND gate is going to get connected to this OR gate. This inverter is going to get connected here. We're going to have two signals coming into there, and we're going to route a signal to there. Oops, sorry, there was a little bit of a mistake there. I meant to do that. There we go. So we got our two signals, and then our inverted signal there, and then our output. So that means that FPGAs have these very complex, well, I shouldn't say very complex, but they do have systems that are pretty extensive for interconnecting all these modules and routing one to the other as needed. And then what that would mean is that these ones, though they would still exist physically, the hardware would be there for them, they just wouldn't be used. Same with some of these other gates. They're not necessarily used, but that's the thing, that's the field programmable part, meaning that we can program these ourselves any way we want, and we can program them multiple times, right? We can change things up. And then so maybe in the next design we might have another gate. We might have another NOT. That's a really bad NOT that I'm drawing there. We have another NOT that's added in there, and that would mean that this would now get used. So that's just kind of the crash course on what's in an FPGA, right? We've got these logic elements that are reconfigurable.